All right, we are continuing with the warm-up explanation. So, if we know.
Good morning, please park your options. Miss White, would you please come to the Welcome Center? Miss White, please come to the Welcome Center.
If we know that this angle, and angle G create this triangle right here, what we should then understand is that we can add these two angles together to get 79 degrees. And we should take 79 away from 180 to solve for angle G. So 180 degrees minus 79, which is the sum of these two angles, equals 101 degrees. Now, let's look a little bit closer at the angle relationships. Let's look a little bit closer at the angle relationships in another triangle over here. This angle right here, angle OPM, MPO, is 90 degrees. They gave that to us. This 90-degree angle plus this 23-degree angle plus angle C also equal 180 degrees, again because they are a triangle. So we are going to take 90 plus 23 and subtract that from 180 degrees to get 67 degrees. Angle C equals 67 degrees. Now, all we need to do from here, because we've used our triangle sums to find these other angles, is leverage these parallel line relationships, okay, for the remaining angles. So let's look at angle A. There are two ways that you could find angle A. Angle A is congruent to angle B because they are alternate exterior angles. This angle right here is corresponding with angle A, which also makes it 115 degrees. Here, let's look at angle B. Don't forget that line GH is parallel to EF and parallel to CD.
Good morning, Mr. Kirschenbaum, please report to the Welcome Center. Mr. Kirschenbaum, please report to the Welcome Center.
And AB. So, what is happening is that we have another set of corresponding angles. Angle B corresponds with angle E, which means angle E is also 115 degrees. Now, there are a couple of ways we can find angle H. We need to understand that angle H is same side exterior with angle G. Same side exterior angles are supplementary, meaning that the two of them add to 180 degrees. So 180 minus 101 gives us 79 degrees. Now, let's keep working up this transversal because we've got these two parallel lines and we've got these two parallel lines and we're almost done, okay? Angle I and angle H are corresponding angles on lines CD and EF. So angle I is also 79 degrees. Now, we can look at this a couple of different ways. We know that angle J, which is 79 degrees, plus this angle right here is going to equal 180 degrees, which makes this angle 101, okay? The other thing we could recognize is that angle G, all the way down here, if we just ignore this line in the middle, is an alternate exterior angle to angle J, which means they are congruent, which means they are 101 degrees, which makes sense because angle J is corresponding with this next closest parallel line, which is also 101 degrees. That is our warm-up. What I would like you to do now is turn to your notes for a series of demonstrations. What we are doing today is we were working with transformations. Transformations are all about how to get from one shape to another. I'll give you some vocab and form definitions in a minute, but what I want us to see and look at initially is how we get from shape A, which is our original shape, to these other shapes, okay? So what I have right here, which you can't really see, is a transparency, okay? So I'm just going to put the transparency on top of this. That's why you see this little bit of glare here. I'm sorry, okay? And I'm going to take my Sharpie and I'm going to trace my original shape. I've now traced my original shape. How could we move the transparency to get from A to D? How could we move the transparency to get from A to D? Notice what happens. A and D are congruent because one shape maps onto the other. But what are we doing to that transparency? We're not flipping it over. We're not turning it. I'm pushing and pulling the transparency to get it adjusted correctly, right? So there's some type of movement there. This, which I will formally define for you in a minute, is one type of transformation. Now, let's look at how we would get from shape A to shape B. How would we get from shape A to shape B? Let's see if the same method works. I've got to fix my transparency. But let's see if that works. Can we just pull or slide over here? That doesn't work. We can't pull or slide. We can't really turn it and get it to work. What if I take my transparency and I flip it over? Notice what I have done. I have flipped my transparency from A. A simple flip takes me to B. From A to B. From A to B. This is a different motion than what we did to get from A to D. Here we slid. Here we flipped. Now, the last transformation that we need to discuss is how to get from triangle A to triangle C. How do we get from triangle A to triangle C? Do we slide it? No, that doesn't seem to work. If we just slide left or right or up or down, that doesn't work. And if we flip it, does that work? No. Okay. What happens if we go from here, put our pencil point in the middle of the graph, also known as the origin, and spin that paper? If I could trace effectively, right, or do anything right, it would work out. Here, I'm turning the paper. So from A to C, I am turning the paper. From A to C, I am turning the paper. Now, we need to define a whole lot of terminology. So, I am going to just take these notes with you. Okay? I'm going to take these notes with you, and you will get it all down in your notes. So set up your notes, and the title for your notes today is going to be Basic Transformations. The title for your notes today is going to be Basic Transformations. Okay? So the first thing that we should probably define, right, and this is a vocab heavy unit, is transformation. A transformation
Miss Fan, please come to the cafeteria. Miss Fan, please come to the cafeteria.